All righty, everyone. Thanks for joining. My name is Randall, and I'm one of the organizers of the Atlanta JavaScript Meetup group. And this is our second time that we are doing a virtual meetup. And so last month we did it at our regularly scheduled time around 7 o'clock at night. And then today we're trying a new time slot. We're trying during lunch. And so appreciate you all taking some time to join us. So before we kind of jump in, wanted to just mention a couple of sort of like housekeeping items within the Zoom client. For those of you joining us in Zoom, you should be able to raise your hand. And that is something that, our presenter may use to kind of, I guess, make sure you haven't fallen asleep. So I guess if everyone could just find that button and go ahead and try to raise your hand within, oh yeah, there it is. Lots of hands, lots of hands. I see some people are sleeping, but nice. And then I guess the other sort of two important things are one, the Q&A section. So if you go into that, you can go ahead and post a question, and that will be visible to myself, Toby, who's also a co-host, and then our presenter, John. So if you have any questions throughout the talk, feel free to drop them in there. John's going to keep an eye on them, and we'll also keep an eye on them. And then also we've got the chat. So if you want to send a particular message or whatever, feel free to use that. So before we kick things off, I just want to take a moment to thank all of our sponsors, starting with Sabah Group. They've been with us really since day one, and they help us out with a lot of the logistics and planning that goes into these events. Next, we'd like to thank Cypress. So if you aren't doing testing, you should check out Cypress. If you are doing testing, you should check out Cypress. If you already use Cypress, you should check out some of the new stuff that's dropped recently. So there's a lot of features within the test runner as well as the dashboard, which are super exciting. And they help us out also with logistics and then also with our Zoom webinar. So they provided this platform for us to use today. And then our last sponsor to thank today is Wrangle. Wrangle is a firm, definitely check them out. They've been a sponsor now for, I think, a little over a year. We really appreciate what they do for us. Also, a big thank you to the organizers. I guess this group of folks is really, they're the ones that make this all happen. It takes a lot of coordination between getting schedules aligned, as well as, just, I guess, really being nimble in today's sort of unique environment. So today's presentation is going to be from John. John is with Charity Vest. And with that, I will go ahead and turn it over to you, John, if you're ready.
Great. Thanks, Randall. Hi, all. I'm John. Just going to get the slides up here. Also, just dropping a link to the slides in case you want to follow along on your own. So I'm going to share my screen. Actually, I'm going to start the presentation first. Let's get this going. Okay. Share. Hopefully everybody can see that.
Looks good.
Cool. Thanks, Randall. All right. Yeah, so I'm John, the CTO and co-founder of Charity Vest. Today, I'm going to be talking about serverless microservices with AWS Lambda and really kind of share some of the things I've been learning, building this product. A little bit more about me. I grew up in Atlanta, went to Georgia Tech, studied computer science, met my wife there. We now have 3 kids. We live in Decatur. I also spent some time in San Francisco working for Twitter. I was there about 7 years. And halfway during that tenure, moved back to Atlanta and worked remotely for them. As I mentioned, I started Charity Vest kind of nights and weekends a few years back, and we just launched last December. So still very early on, so learning a lot, having fun. And yeah, I'm passionate about JavaScript, kind of been doing JavaScript for 10 years, definitely a passion, and doing web development, really like user experience, design systems, and more recently, cloud and serverless computing. So cool. I just want to give an overview of what we're going to be talking about today. I just don't want to assume any prior knowledge, so I'll try to cover the basics. So we're going to be talking about some AWS building blocks. And you'll notice throughout the talk that I'm talking about AWS because that's what I'm the most familiar with. But all of these primitives and concepts are, applicable to Google Cloud and Azure. And then we're going to talk about basic definitions of serverless, microservice, the microservice architecture, and then we're going to look at a case study of this statement service. Sorry, I got distracted a little bit trying to coordinate the Zoom chat and make sure I'm responding to everybody as that's going on. Feel free, as Randall mentioned, to drop things in the QA. A bit of a distraction for me, so maybe I'll just wait till the end to answer any questions so I can kind of keep going. But yeah, and then we're going to hopefully look at some code. It's a pretty high level talk, but there is some code here to get you engaged. All right, so AWS building blocks. Kind of the first building block we've got with AWS, and I think it's one of the first services that they made publicly available even, is S3. Stands for Simple Storage Solution. It's blob storage. Basically, you put anything in here that you wouldn't put in a database. So big binary files, images, PDFs, CSV files. That's S3. And then there's AWS Lambda. This is their function as a service offering. It lets you run some code in what's called a micro VM. AWS recently open sourced this. I think it's called Firecracker. Fortunately, we don't really have to know or understand that. That's kind of the beauty of the serverless offerings, is they're fully managed in the cloud, and you just get to run your code. And you only pay when your code is running. There's no servers to provision, manage, or scale, built-in load balancing. For AWS specifically and Lambda, they support Java, Go, PowerShell, C#, Python, Ruby, and of course, Node.js out of the box. I think you can add support for other runtimes as well. All right, moving along, CloudFront. That's AWS's CDN offering, or content delivery network. So they have these POP servers, or point of presence servers, across the globe. And the idea is to get these servers as close to your user as you can. That's why Netflix streaming is so good, because you probably have a Netflix POP like a mile or so from your house if you live in a populated area. But yeah, CloudFront is AWS's CDN, and you can use it to reduce latency to your user. It also acts as kind of a router for a domain. So in the case of CharityVest, we host our API at charityvest.org/API, and we can kind of control that at the CloudFront layer. Basically, these routes go to this origin server. These other routes go to this other server. So SQS is their managed queue service, or simple queue service. So it's a job queue or message queue. You've put messages on it, and then you have some kind of compute that is processing the messages or the jobs. And Lambda can connect directly to a SQ to process these messages. And here's a little quote from the AWS website. It says, using SQS, you can send, store, and receive messages between software components at any volume without losing messages or requiring other services to be available. And that last little bit, requiring other services to be available, is pretty important to ensure your systems are reliable, and you have a little buffer, especially with your third-party integrations, in case they have downtime. You don't lose any of those messages. So let's talk about serverless. So serverless, and these are kind of my own definitions of it. Serverless allows you to build and run applications with less concern for servers. So you can't SSH into a box or like add a library to it, or you don't have to do any operating system maintenance or patching or scaling or capacity provisioning. You don't have to plan months in ahead to make sure a machine gets into a colo or whatever. Just use what you need when you need it and pay for what you need. And so you're not paying for warm servers. You're just paying when your code is running. Lambda, at least early on in my journey here, I kind of saw Lambda as kind of synonymous with serverless, but serverless is more than just compute. So serverless, is basically all of these services that you have this kind of same characteristic of you don't SSH into boxes, and you don't have to patch operating systems, and generally you just pay for what you're using. Lambda, SQS, SNS. One we use at CharityVest called Cognito is basically like authentication as a service. So like email verification, password, all that stuff. All right. So let's talk about the microservice architecture quickly. There's this really funny video that came out recently. You should check it out. It's very almost like a documentary. My time at Twitter, which was like heavily adopted microservices, a lot of this is really funny to me. Even like the joke names for the systems, like that was just like really prevalent, and that basically these things can get out of hand. But also, there's reasons these big companies adopt these, extravagant architectures. But anyway, you should check out that video after my talk if you haven't seen it already. So let's briefly talk about the architecture. This is like a real simple example of that image. On the right-hand side, you've got your UI or your front end, and then you've got that UI is communicating with different services to get different data and update different data. And a lot of times these microservices, you'll notice at the bottom there, the lines between the service and the database, there's just one line there. So the microservice is kind of acting as that API to that data, and it kind of owns that database. And I think that that's really important. It allows you to do database migrations and kind of understand how the data is being used, because you have this kind of narrow API that you're exposing with your microservice. And that happens over the network generally. Microservices can be deployed independently. Well-designed ones have a single responsibility. And as I mentioned, they generally control their own data store. So this is a book that I've been reading as a part of this journey. And kind of early on in the book, they offer like 5 different definitions for this microservice architecture. So obviously it's not super locked down, the definition. But one of these definitions is a microservice is an independent software component that takes no more than one iteration to build and deploy. So if you're doing like 2-week sprints, you can imagine, building a system in 2 weeks and deploying it. And that, one thing I like about this definition is it focuses on kind of the scope, like how much can you realistically get done in 2 weeks? And like that's kind of the scope, and that's where the micro and microservice kind of comes in. Obviously, you're going to be maintaining these things over the long term. It's not generally a build and forget, although that is one nice thing about them, is that sometimes it works out that way. All right. So let's talk about microservices compared to monoliths, and that's not the focus of this talk, but I think it's value to have the comparison, so we have a better idea of kind of the trade-offs and the benefits of each. So monoliths are the monolithic architecture is typically like your Ruby on Rails type app, where you've got your object relational map or your data access, you've got your business logic, you even have some HTML rendering happening on that one kind of integrated system. Is another term that's being used for this architecture. And it has a lot of benefits. It usually has a good local dev story. It's, just like one thing to deploy. Typically uses object-oriented approaches to reduce coupling between components. And then also typically one kind of disadvantage of monoliths is that you can't tune them for special workloads. So if you were doing, at least generally, you could do multiple deployments of the same monolith that has kind of different memory and CPU needs, and you could just like send certain jobs to that deployment. But generally, you would just have to kind of scale it for the largest need. If one particular workload on the monolith needs a lot of memory, you need to give every workload basically that memory and that CPU. So let's talk about microservice benefits. Kind of on that point, one thing that's nice about them is they allow that fine tuning of resources and infrastructure for various types of workloads. Imagine doing some image processing, or as the example we'll allude to later, like generating PDF that requires like a lot of memory and CPU, and kind of shielding the rest of your workloads and only paying for what you need, right? So microservices pair well with DevOps practices of like a you build it, you run it mentality. And encourages decoupled componentization because the services are forced to communicate over the network. So because you don't have this like memory access to objects and libraries, you have these more narrowly defined REST, typically REST, or maybe something more complicated like a binary messaging process. It's like not JSON. Those technologies are, I'm kind of forgetting what an example of one of them, but I think you guys know what I'm talking about. But yeah, and these microservices, they're smaller systems, a little bit easier to reason about and refactor on. And this last point is the one that that is kind of near and dear to me, and kind of one of the reasons that we started using this architecture at CharityVest is because, like, for example, we're dealing with money. We have this, we now have this one service that's like our transaction service, and like we want the test coverage of that service to be like super high, and like kind of all the like functionality around transactions, it's kind of all related, and there's just like different practices. There's a different way we treat that system in comparison to maybe our organization search system, which maybe if it has downtime or some bugs, yeah, it's a big deal, but it's not as big a deal as like putting the wrong money in the wrong place, or whatever. All right. So one thing about microservices, though, which we probably all are aware of, is they're typically employed by larger teams. Typically, it is like an organization scaling. It is a way to scale like a human organization, right? Because you can be like, okay, you 5 people, you're in charge of this one system, and take care of it. And then you can just communicate with the other teams via these like APIs that you define. Like, oh, we need your system to do this. Let's define this API endpoint for that. But it's really costly for small teams if you don't invest in automation DevOps. And it's also really expensive to run these services if you don't have serverless. So that's like kind of the next slide. For small teams and fledgling startups, the monitoring cost of like traditional microservices running on warm servers, like just machines that are running whether they're doing work or not, it's just like, it doesn't work. So like consider the case of like, if you had like 10 services and you like, if you're doing a good job, you want to put at least 2 servers behind a load balancer in case one of them dies. So if you have 10 services, that's 20 machines right away and like, I think we can all do the math there, like running 20 machines, is just really expensive. Right. And so that because of the cost, you're going to be like, well, this architecture cannot work for us. That's too expensive. We need to build a monolith, right? To just have this one deployment, one server, one system. And that's kind of where serverless and microservices come together. It makes it practical to do microservice architecture at like a smaller scale. And obviously there's huge benefits for a big scale as well. But what I want to focus on today, and what I'm like a big benefit I'm familiar with right now, is just this ability for a small organization to adopt this architecture via serverless. As I mentioned, it's pay per invocation. And you can afford to have a service that you don't use very often, available at a moment's notice, because you only pay for it when you're using it. So one kind of warning that I've kind of alluded to is that, like, you have to invest if you're going to take this approach. You have to invest in infrastructure. You have to automate everything. You have to have really robust continuous integration, continuous delivery pipelines. When you have a monolith, you can afford to deploy it once a week or deploy it daily. But when you have 10 services that you're running, you don't want to do 10 deploys every week. But if it's all automated, absolutely deploy every change. That's what we do at CharityVest. Every change, runs through an integration pipeline, and it gets deployed right away. And that has a lot of other benefits too, right? That means that when we find bugs, we can revert them just as quickly as we created them. So another thing on this infrastructure topic, we found that the monorepo approach is really important. You don't want to be publishing. You probably want to be sharing some code between these services, right? And you don't want to be publishing libraries and utilizing this. It's really time consuming. Like, you want to have your shared libraries as source dependencies. So every time you deploy that service, basically you're deploying the latest version of that internal library that depends on. And in the JavaScript ecosystem, you can get this with like Yarn workspaces and Lerna. So I feel like this stuff is a little bit new. So there's, I think serverless and like the monorepo, both of these things are a bit new. So there's definitely some investments you need to make to get it working, but it's like well worth it. All right, so let's talk about a case study. We're going to talk about the statement service at CharityVest. So just a quick background on the company. I've already talked about it a bit, but so we're an Atlanta-based fintech company in the charitable giving sector. It's like a Venmo for giving. The premise is, as a user, you put money in your fund, you get an immediate tax deduction, and then you can choose from over 1.4 million nonprofits to give to. You saw that word tax deductible in the bullets there. And so tax statements, tax receipts, like that's an important part of the business. So we have a service that's responsible for that, and that's what we're going to be talking about. So you're probably familiar, if you've given to a charity of any kind, you're probably familiar with this email, okay, your tax statement. So, and you might click that button, and then you might get this screen that says, okay, I can look at my tax statement. You can click that link and you might get the PDF, right? So let's talk about the architecture behind this system. So, so in our world, tax time comes, late January. We want to generate all these PDFs for all of our users. So we've got our statement service. It's a Lambda. And basically what it's going to do is it's going to talk to our database. It's going to get all the information for all the transactions. And we use handlebars as our kind of server-side templating framework. So we generate some HTML that looks like that nice PDF. But the thing is, we want to get that converted to a PDF. That's what users expect, to be able to download that that one file, be able to print it. It looks nice. And so so the architecture we've chosen is we basically generate that HTML. We put it in the S3 bucket. The little green bucket is a S3. It's got this HTML in bucket. And basically the statement service talks to another service that we've created called a PDF service. PDF service's whole job is take HTML, turn it to a PDF. And so the statement service says, hey, PDF service, I've just dropped this HTML in. Can you let me know when the PDF is ready? And so and the PDF service is actually also running a Lambda, and it's using this really cool technology from the Google Chrome team called Puppeteer. It turns out that Google Chrome is like a really good technology to take HTML, convert it to a PDF, and somebody's put together some libraries that allows you to run that in Lambda. And as I mentioned earlier, like this service needs like 1.5 gigs of memory to do this one job. And that's where this microservices thing really shines, right? We were able to give that one system the memory that it needs to do its job. It just does that one thing. And I actually, this is a case where I haven't touched that thing, and probably, hopefully won't even have to touch it next tax time. Its job is so simple. Take HTML in, produce a PDF that I probably won't ever have to touch it. So yeah, so continuing with this system, the PDF service, drops the PDF in the S3 bucket, and then the statement service basically inserts a record for that user, basically showing that that PDF is available, so that when they pop up their statement screen, they'll see that link to view the PDF. And just one call out here. So the kind of the pattern we're using here with the line between the lambdas, this can also be done with AWS step functions, which is kind of designed for this, this purpose of one lambda doing one thing, another lambda doing another thing. And it's super cool. We haven't, for this particular feature, I just needed to glue two lambdas together, so I didn't invest in learning that. But that is kind of the best practice when you're kind of doing these kind of stepwise functions. So you should check that out. You have a similar problem here. So let's keep going here. So this is zoomed in of the same kind of process. You can imagine this is still part of the whole tax time thing. So when that PDF is ready, the statement service knows it's ready. Then it's gonna move the PDF to this secure document storage. So it's gonna pull it out of that PDF bucket, put it in this this other S3 bucket that is namespaced on the user's ID, and that becomes important later. And then I think I already mentioned, it records that the statement's available in the database. And then the final thing that it does, a part of this job, is it sends the user an email. So the statement service puts a job on this other service, the email sender puts a job on its queue, and then that email sender attempts to send the email with our transactional email service Postmark. And if for some reason Postmark is having downtime or just has a little blip, the email sender will error out. That message will get popped back on the queue and retried. And if in our particular case, we've configured it to retry 3 times. And if it fails, it will go to what's called a dead letter queue. And then we'll get alerted and we'll have to figure that out. What's going on? Is Postmark down for days, or what's the deal? But anyway, for the most part, that just those 3 retries has been really good to ensure reliability of these emails and not dropping jobs. So cool. I promised we would look at some code. And this is super high level, but this is directly from our repo. I didn't edit it at all. And it describes basically it's the code for the last 3 slides. So you look at line 7 is kind of the opening of this generate year-end statement function, and it's taking a message from the statement services queue, and the message says basically for this user and this year generate a statement. So the first thing it does, it grabs the user. Then it hands that user ID to this generate year-end statement HTML function that generates some HTML as a string. And then it hands that HTML directly to this PDF client, which does all the work of putting it in the bucket, talking to the PDF service, getting the location of the PDF once it's done. And then on line 16, we move the PDF into the secure document storage for that user. On line 22, we add the statement to the database, and then finally on line 28, we send an email to that user. And you'll notice the little on line 27, we basically have ability to process the statements without notifying the users as a part of this process. And maybe we're doing some testing and we want to do it on production data. We can just kind of run this without bothering the users or something. So yeah, so remember this email. So you click that button and then you go to this page. So let's talk about this page. How does this page work? This deals with our API service, another Lambda. So the way that this works is users go to that page. We make an API request for the list of statements. And there's kind of 2 things that are happening here. One is we talk to the database, and then to get this list of statements that we inserted. And then the other one is that we create this signed cookie using this CloudFront key. And what this signed cookie does is it, which we'll see on the next slide, or in a few slides, it basically allows the user to access the PDF. Let's go to the next slide. So let's look at the code for this. This one is doctored a little bit. But yeah, it's really simple. We use Express. So you can run Express and Lambda, and with some special libraries. And yeah, so it's gets the statements, signs the cookie, and then returns the cookie and the JSON. All right. So here's the PDF, right? And ideally we want to deliver that PDF securely for only that user. Like ideally they've authenticated that they can view it, and no one else should be able to view it just because they have the link, right? They should only be able to view it because they like logged into the account. But at the same time, we don't really want to stream the PDF file from our API. It's just not designed for that. It turns out that, you know, CloudFront and S3 have this really cool way that you can secure a static file like a PDF. So basically what's happening here is that the browser makes that request, and we have in our CloudFront configured, okay, this path, you know, connects to this file in S3. And this particular document in S3 has to be secured. And so with the request comes the signed cookie, and that cookie, the cool thing about that cookie is that it allows the user to access any of the documents that are like namespaced within their like special folder in the bucket. And so if you could imagine that statement screen having like 30 documents on it, you know, this one cookie kind of allows them access to all of those statements. And then CloudFront basically gets the PDF from S3 and, you know, and just returns it to the user. And the cool thing about this is that there's no code here, right? So we already basically, this is the dream, right? We just did a little configuration with CloudFront and S3. And, you know, they're handling all of the, you know, sending of this PDF securely to the user. Well, cool. I actually made it through this a lot faster than I was expecting. So we should have some time for Q&A. So that looks like there were three questions at least. And feel free as I'm answering these questions to type some more. So we have a little more content here. So Charlene Woolley asked, John, how does the VM factor into play here when compared to serverless? Okay, yeah. So yeah, and I assume that that question probably relates to when I mentioned the micro VM or the Firecracker. So kind of that's kind of what's happening under the scenes, right? So in your, you know, traditional, you know, pre-serverless era, you know, you might spin up these virtual machines running Linux, and and in the case here with serverless, AWS has basically created, like fine-tuned these virtual machines that are like crazy fast to boot up, execute some code, and then kind of freeze or shut down. And so there's still a VM involved. It's just kind of, it's nothing that you have to manage. So that's a really good thing. All right, so Charlene Woolley asks next, do you include encryption for the user's information? Example, in the email. Yeah, so encryption. Yeah, so basically all of there's various places in this architecture where encryption might be involved. You know, like with communication with the database, or like, is there encryption at rest for the PDF and the S3 bucket? or like how do you connect to your third-party email provider. So all of those things, we use kind of standard encryption practices. Yeah, so Justin asks, why Express rather than API gateway? Yeah, so I think for us, it's somewhat, well, first off, it's actually both. We do use API gateway. We use this framework, I think it's called HTTP-serverless. And what it does is it takes the API gateway formatted JSON payload, and then it converts it into request that it hands to Express. And really the reason for this is that we actually started building CharityVest using Elastic Beanstalk and with an Express server. So it's somewhat a migration strategy. It basically allowed us to put our existing Express API service in Lambda without any code changes at all. And then it also provides a nice local dev story because we can just start up our Express server. And there's some drawbacks to that. Like ideally, we would be using something like the serverless framework. But at least for us, this has been a good migration strategy. And again, we are using API gateway. It's just really that Express is involved as well. So Rusty Bailey asks, had you done serverless before this? If not, what made you want to attempt this, and how did you go about learning all the AWS related pieces you needed to glue it together? Yeah, so I think this was not our first serverless system. The first thing that we made serverless was our API. And for us, one of the biggest draws was only paying for what we use. That's really important for us as a fledgling startup. And also, it was one of those things where I was like so sick of dealing with Elastic Beanstalk. And the thing that we were running a Docker container in Elastic Beanstalk, and there's like so many layers of complexity there. It's like you've got the load balancer, and then you've got you've got the machine that your Docker container is running on, and you have your code in the Docker container, and that all those levels of abstraction just were causing problems for us, and it was expensive. And yeah, so that was kind of the impetus, as we were just kind of struggling with Elastic Beanstalk and kind of saw an opportunity to save cost and to make development a little bit easier. And in terms of learning all of this stuff, it was very much piecemeal. Like as I had a problem, I would just kind of consume all the documentation for that particular component, and then apply it to my problem. I think that for me personally, that way of learning, attacking a problem, is good. So Randall, are you wanting to answer this? I'm kind of new to this Q&A thing, but it says Randall Kent's going to answer this.
No, I wasn't going to answer it. I was just marking it as that you will be answering it live.
Got it. I'm sorry. All right. Let's go to Brian Mullaney. Could you share how you handled the PDF conversion in Lambda? We've had issues with Chromium-based modules, password relation name code size maximum. Also, are you using a specific HTML PDF node module? Really good question. And I can post some details about this later. But the key here is that we're using Puppeteer, and you talked about code size. And for Lambda, they have this special functionality of Lambda called Lambda layers. And layers basically allows you to stick your dependencies in it's almost like your node modules can be in this layer that your application code can utilize. And because Lambda does have code size limitations, but the limitations are different for a layer versus application code. So that somebody has actually packaged Puppeteer in a layer that you can just kind of use directly. And I think AWS intended for these layers to be, and I'm sure they are used this way, for these layers to just be this kind of thing that we're just sharing in the developer ecosystem. For me personally, I kind of wanted to own the layer. So they do publish the code, the node modules library, and that just kind of fits in with our workflow. We use layers. Basically, all of our node modules we put into layers. And the nice thing about that is it allows our application code to be editable within the AWS UI. Because if you get to a certain code base size, then you can no longer use the online UI. Not that we use that a whole lot, but anyway. So yeah, the answer is it's Puppeteer, and I can't remember the exact name of the library, but I will try to find that and maybe post it on the Meetup forum or something like that. Hi, John. My question is rather, so this is next question. So hi, John. My question is rather basic. Could you please explain functions as a service again? Yeah, no problem. So function as a service, it's basically a way to run your code in the cloud. Yeah, that's really, there's some kind of trigger. Maybe it's API gateway saying, hey, there's a request, or maybe it's an S3 bucket being like, hey, somebody dropped a file in this bucket. But there's some kind of trigger point that like executes your code. And then you get to do whatever you want in the Lambda. And once it's done, it stops executing, and then, it did its job. And that's the whole thing. It's just like run your code in the cloud, only pay for when it's running. So that's the idea. Julian, how do you test things in development? Do you just rely on unit tests given each service is small? So that's a really good question. So we prefer to use integration tests for our backend. And I mean, we have a mixture of unit and integration. But yeah, the way that we write our tests for our backend services is we actually will have in local dev and in our CI system, we will spin up, in our case, we use PostgreSQL, which is not a serverless service. It is a warm server that you pay for when it's not doing anything, but has some other benefits. But anyway, so we use PostgreSQL, and yeah, so when we're writing our tests, we'll basically execute, one of the code paths, and then we'll actually do assertions directly on the database to make sure that everything got written correctly. So and that's considered an integration because it's not using like SQLite. We're not mocking out the database. It's like full, it's mostly end to end. Cool. And yeah, the size of the microservices does make it a little bit easier to kind of like test the pieces of functionality. For the case of the PDF service, there's no test coverage at all. I know that sounds kind of silly, but it's just like its job is so simple that like, you can basically manually test it as you're working on it. And you're not touching it a whole lot. And that's really where the unit integration tests like really buy you a lot, right? When you have a lot of hands like mucking around with that code, you want to ensure that it just continues to work. When you have something really simple that just takes HTML and creates a PDF, it either works or it doesn't, and you can kind of manually test that. So great question, Julian. So Justin, that makes sense. Also, lets it be multi-cloud more easily. Yeah, that's true. Yeah, and kind of on the multi-cloud topic, there are frameworks out there like Terraform or like the serverless application framework that offer these kind of multi-cloud solutions where you can basically write your code against the serverless framework, and then you can easily move from AWS to Google Cloud or we haven't personally adopted or thought that was useful for us. We're in the camp of like, if we can utilize something that is, somewhat proprietary to a specific cloud, then it just makes development a lot easier. We can take advantage of more functionality. And the reality is that we don't plan to like change clouds. I don't know the reason we might is maybe to save cost, or maybe we just like the UI of Google Cloud better, which is probably true. But we've kind of bought into AWS and kind of have taken that position. Cool. So this question from Brian, are you doing anything on the API Gateway Express function to mitigate cold starts? So this is a really great question. So cold starts are kind of a situation with function as a service. We talked a little bit about that micro VM, and it has a boot up cost. They're designed to be very fast to boot up, but they do take a second or two to start up. And if you want millisecond response time, you want millisecond latency on your API, like ideally you would, then Lambda may not work well for you, or like serverless may not work well for you. There are a lot of techniques to prevent these cold starts from being an issue, though. I think actually in December, AWS announced this man, what do they call it? It's called like reserved concurrency, I think. And basically allows your Lambda to just always be warm. It kind of mitigates the cost only pay for when your code is being executed thing, because you basically just pay for that VM always running. But I think there's still some advantages. We don't do that. We do use this little library that will like ping our Lambda to kind of like keep it warm. And in practice, it doesn't work super well. Like our users do experience cold starts. In my opinion, like at least for our particular application, this is not an issue. Like there's ways to kind of improve the perceived performance of the application and the UI. And for us, it's more important to, only pay for what we're using. But yeah, there are some techniques to mitigate that. And in the future, we may choose to mitigate this cold start problem with the reserved concurrency. I think that's what it's called. For some special services that latency does matter, like our API service. For like the email sender or like the statement service or PDF render, these things don't matter at all. They're not user facing. So cold starts are not a problem. Cool, thanks. Great question, Brian. So Alberto asks, would you move a large API backend like 700 to 900 methods to a pure serverless framework with Express or just Lambdas? Yeah, this is a really good question. Yeah, this is kind of like my first response would be like, you need to like look at your business and your company and decide kind of what is your problems that you're what are the problems that you're having right now, and is serverless going to solve those problems for you? If, for example, like you just have, you're already running your API in Kubernetes or whatever, and it's working really great for you, and the latency is really great. I don't know if that would be worth it to migrate to something like serverless. But if, for example, you're having kind of like in your company, this sounds like a large code base, 700 and 900 methods. I assume those are like roughly routes. That sounds like a big code base to me. It also sounds like there's probably a lot of people on that team. There may be opportunities to break off, microservices out of that backend to kind of take advantage of, to get some of the other advantages of a microservice architecture. And if you're doing that, you probably should consider serverless for that migration. Again, you probably don't want to end up in the situation where you're paying for minimum 2 servers behind a load balancer just because you wanted to break 5 of those methods into its own deployment. Probably not worth the cost, but serverless kind of makes it possible for you to make that type of decision. Really good question, and I apologize that it's not a black and white answer. It's more like what is the problem you're trying to solve, and does serverless kind of meet that problem? All right. Dimitri, how do you go about integration testing your system? So I talked about that one a little bit. I'm gonna skip that one since we kind of already talked about it. Asher asks, would the volume of traffic determine whether or not serverless API gateway would provide cost savings as opposed to more traditional monolith setup. Yeah, it's a really good question. Yeah, the volume of traffic. Yeah, I think if you're just going for, if the reason that you're choosing serverless is primarily about cost, then you would need to evaluate your particular workload. I haven't done the math myself, but my understanding is that these function as a service offerings are some of the most expensive compute that you can buy. So like if you were running a system on EC2 for 24 hours, 7 days a week, and then you ran that same workload for that 24 hours, 7 days a week on Lambda, the Lambda would be more expensive. But the reality is that most people are not taking full advantage of their EC2 instances. So they're basically paying for the server just sitting there doing nothing. And so in that case, Lambda kind of unlocks this ability to only pay for what you're using. So yeah, the volume of traffic is definitely a factor. And because if you are utilizing the full capacity of your servers, then it might be cheaper. I don't think the cost is like the most important factor in serverless. I think probably the ability to not have to manage servers is really valuable, and that's a different kind of cost, and it's a cost that we sometimes forget. Is like, how much does it cost my engineers and my DevOps people to run these systems? That like the salaries of the engineers in your team are probably the most expensive thing in your organization. And so if you can save money there by kind of lowering your operational cost, and then that's a win. So I would consider that in the calculation as well if you're making a cost benefit calculation. Julian asks, how do you maintain and configure AWS resources? Do you keep the configuration along with the code? So this is a concept that's called infrastructure as code. I'll say that what we'd like to be doing is having everything defined with infrastructure as code. In reality, we've got, it's a bit of a migration that we're in the middle of. I mentioned Terraform and serverless earlier. Those are two technologies that kind of allow you to do this infrastructure as code concept. And this is one of the things that, one of the reasons I think that this is critical is, for example, in the case of CharityVest, we would love to have our staging or almost like our user acceptance, our UAT environment to be near identical to as much identical to production as is possible. Like in our case, as a financial services firm, maybe we're using just the sandbox APIs for our ACH provider and stuff like that. But other than that, we want everything to basically be identical. And this infrastructure as code solutions, like Julian's asking about, makes that much more possible. If you're clicking around in the AWS UI or Google Cloud UI to configure these services, like that's not ideal because it's not, you can't code review that, you can't replicate that easily. You're going to forget. So we're kind of in a migration right now. We do have some configuration as code with our Lambdas, but some of the other things that are a little more like one-off, like for example, our CloudFront configuration. We do not have that as infrastructure as code, but it's really important. There's no reason not to do that, and it's like really important. Robert Jones asks, what influenced you to develop on AWS rather than Google, Azure, or another cloud platform? Yeah, it's a good question. I will say I had a lot of my friends in the tech scene have been moving from AWS to Google Cloud, and having experienced a little bit of Google Cloud, like that is the one that probably I know has like a really intuitive and nice UI, and probably the services and APIs are a little more intuitive. So if I were to start from scratch today, I might evaluate a little bit more Google Cloud specifically. For the reason we chose AWS is because it's the market leader. Like everything you could want in the cloud, like AWS has an offering for it. And I almost feel like on a daily basis, I'm finding out about some new service that AWS offers that is, amazing. And, you're just not going to find it anywhere else. A really interesting example for CharityVest, being the financial tech space, is they have this database called Quantum Ledger Database. And it's actually it's basically like a private blockchain as a service. And the benefit is that the transactions are append only, and it's got a built-in like audit trail of everything that's happening in transactions. And it's like performant and it's serverless. It's built for financial services companies. And you just can't get that type of specific technology from the other clouds. And as I mentioned earlier, like we kind of decided early on, we're going to go all in on AWS and just take advantage of all these obscure things. And we're not going to worry about trying to, move clouds or whatever later. All right, so I'm gonna kind of scan through these. We've got 4 more questions. I think I probably have time for 1 or 2 more. Okay. Here we go. I'm gonna skip to the end here. What would you recommend for a newbie starter, AWS or GCP? Please cover the angles of learning curve, features, and job market potential. Sorry, off topic, but much appreciated. Yeah, it's a really good question. So yeah, I kind of alluded in the last question that I think Google Cloud is like definitely up and coming. That being said, AWS is definitely the market leader. I think you're more likely to find AWS in the organizations that you'd be applying for. Yeah, so I think for a newbie, I think AWS probably does have a higher learning curve in some respects. So I remember struggling early on with like the IAM policies and stuff like that. But again, I don't have direct experience to kind of say you should definitely do this as a beginner. I think if you look just from maybe the job market potential lens, I think AWS is probably a good one to go for. And the reality is that I think you're going to be able to apply all the same principles that you learn doing AWS to these other clouds. And I think that a company using Google Cloud is going to be much more likely to be fine with you having experience with AWS because most of their candidates are going to be more likely to have experience with AWS. So, well, cool. So that's done with the Q&A. Thank you so much for all the really good questions. That was great. So last slide here, let's connect. Got my email here. I also, I'm on Twitter. I tweet about, right now I'm doing Ludum Dare, so I'm doing this stupid game, so you can watch that happen. But also just tweet about technology and design systems and other stuff. So follow me there, email me. Also, CharityVest, we're looking to hire another engineer this year. So you can apply at that link or go to charityvest.org and click on careers. So that is it for me. Thank you so much, everyone.
Awesome. Well, thank you so much, John. That was solid. I would say that that was probably one of the strongest Q&A sessions we've had. So maybe it's the lunchtime aspect of it, or maybe it's the topic or a combination of both. So just a couple closing slides. See if I can get them to come up. There we go. Community sort of notes, Refactor Tech has been rescheduled. Definitely, check it out. It's currently scheduled for August. We've got a promo code for $50 off. Render ATL also in August coming up. Check them out. And then some other meetups that I'm honestly not 100% certain if they're still going strong right now, doing virtual content instead. But we've got React, the Angular meetup. And then I think we got one more community announcement, and that's Drupal Camp. They're still looking for proposals. So they do a lot of like decoupled stuff. So they do a lot of JavaScript front ends using kind of Drupal as the back end. And then John, we got you in here again, just a double hit for whether for folks that might be interested in working with you. We've got a call out there. And then Saval Group is also hiring, as is Cypress. And then last but not least, definitely check out our discussion board if you have an opportunity that you're looking to share, or if you are looking for a position yourself. A quick note to follow us on Twitter, ATL JavaScript, and then also on YouTube. So now that we are streaming these live, the live recording automatically gets posted to our YouTube channel, and you can view a lot of our older meetups there as well. Definitely check it out. If you're interested in speaking, want some feedback on your talk, Rachel is down to give you some feedback. You can shoot her an email there. And then last but not least, my favorite slide, a candle loses nothing by lighting another candle. So John is nothing less. Everybody that participated here is something more. So if you want to present or help us promote or plan any of these events, we would love to hear from you. You can shoot us an email at present@atlantajavascript.com, or you can hit us up on Twitter, or send a pigeon. Really anything that is socially distant is appropriate. So thank you all for joining us, and we will see you next time. Take care. Bye.